Scientific exploration of space allows us to better understand the origin of the universe, the formation of galaxies and stars, and the existence of mysterious objects such as black holes. Each new discovery raises new questions and astonishes us with incredible facts. In 1996, when the National Aeronautics and Space Administration, NASA, began work on replacing the Hubble Space Telescope and creating the next-generation James Webb Telescope, the goal of the new telescope was to unravel the mysteries of our solar system, peer into distant worlds around other stars, and explore the mysterious structures and origins of our universe and our place in it. On January 9, 2022, the James Webb Telescope successfully deployed all of its systems and went into full operation. And on January 24, 2022, it was sent into halo orbit at the Lagrange point L2, which is 1.5 million kilometers from Earth. For several weeks, cooling of the telescope to operating temperature was carried out. Then the calibration process began, which took about 5 months. After that, the telescope was ready for the research program, including the first images of the universe. The James Webb Space Telescope has helped scientists discover the most distant active supermassive black hole, a region of space in which the gravitational pull is so strong that nothing, including light, can escape. Black holes are formed by the collapse of very heavy stars, when the core of the star shrinks to an extremely small size and forms a point of infinitely high density called a singularity. There is an event horizon around the singularity, which is the point beyond which nothing can escape once inside the black hole. The gravitational pull of the black hole is so strong that it warps space and time in its vicinity, creating very strange physical phenomena. But how could they see it? It is impossible to see a black hole directly because it absorbs light and does not emit it. However, we can detect a black hole and study it through observing its effects on the environment and through space telescopes. One way to detect a black hole is to observe its interaction with surrounding stars or gas. If a black hole is near a star, it can pull matter from the star with its gravitational pull. This matter, falling on the black hole, can heat up and emit X-rays or gamma rays, which we can record with special telescopes in orbit. In addition, observations of the accretion disk, a ring of gas and dust orbiting a black hole, can also help identify it based on the bright radiation that is produced when matter falls into the disk. The recently launched James Webb Telescope provides new opportunities to study black holes at finer resolution and in other ranges of the electromagnetic spectrum. It is equipped with instruments that can observe X-rays, infrared, and visible radiation, helping to expand our ability to study black holes. When scientists studied the galaxy CEERS 1019, which existed just 570 million years after the Big Bang. And most interestingly, the black hole in this galaxy turned out to be less massive than any other black hole we've ever discovered in the early universe. Scientists also discovered 2 other black holes that were smaller and existed 1 and 1.1 billion years after the Big Bang. These are very important discoveries that help us better understand the early evolution of the universe. But how did scientists manage to make these discoveries? Well, the James Webb Telescope is equipped with special instruments. It is equipped with a huge segmented mirror with a diameter of 6.5 meters, consisting of 18 hexagonal segments. This mirror provides the collecting power and high resolution of the telescope. It is also equipped with various scientific instruments including cameras, spectrographs, and coronagraphs. It creates high-quality images in the infrared and collects data called spectra. Scientists have used this data and images to make these amazing discoveries. The galaxy CEERS 1019 not only attracts attention for its long existence, but also for the surprisingly small mass of its black hole. Its mass is only about 9 million times smaller than other black holes in the early universe that we typically detect. Typically, such black holes have a mass of more than 1 billion times the mass of the Sun and are bright because they actively absorb surrounding material, which glows as it falls onto the black hole. In contrast, the black hole in the CEERS 1019 galaxy is more similar to the black hole at the center of our Milky Way galaxy, which has a mass 4.6 million times that of the Sun. It is also not as bright as the more massive black holes we have previously discovered. Scientists have always known that small black holes should exist in the early universe, but it wasn't until the James Webb Telescope that they were able to make the discoveries. The data collected by the telescope is full of accurate information that scientists were able to extract. They analyzed the emission spectra to determine which radiation comes from the black hole and which from the galaxy, and to determine the amount of gas absorbed by the black hole as well as the rate of star formation in the galaxy. The first black hole they discovered is in the galaxy CEERS 2782. It was relatively easy to detect because no dust obscured the telescope's optics. Scientists could determine when this black hole existed in the history of the universe just 1.1 billion years after the Big Bang, an event that occurred about 13.8 billion years ago and is the beginning of our universe. Thus, the black hole in the galaxy CEERS 2782 existed very early in the history of the universe. But that's not all. The research team also discovered a second black hole in the galaxy CEERS 746. This black hole existed a bit earlier, just 1 billion years after the Big Bang. What is surprising is that the second black hole they discovered still has a bright accretion disk, which is a ring of gas and dust surrounding the supermassive black hole. This accretion disk is a source of bright radiation as matter falls onto the black hole and heats up to very high temperatures, emitting energy in various ranges of the electromagnetic spectrum, including visible light, X-rays, and gamma rays. Observing the bright accretion disk around a black hole provides scientists with the opportunity to study the physical processes that occur in the extreme conditions near black holes and understand their impact on the evolution of galaxies and the formation of structures in the universe. However, part of this disk is still covered in dust. As Koksuski explained, the central black hole in the CEERS 746 galaxy is visible, but the presence of dust indicates that it may be inside a galaxy that is actively ejecting stars. Previously, such black holes were too faint to be detected by other telescopes. But thanks to spectra from the Webb telescope, scientists have been able to accurately measure the distances and ages of galaxies in the early universe. The researchers determined that 11 galaxies existed between 470 and 675 million years after the Big Bang. And these are not only distant galaxies, but it is also striking that so many bright galaxies were found at such an early stage in the evolution of the universe. The research team was amazed at the number of detailed spectra of distant galaxies that the Webb telescope was able to obtain. This discovery, together with future studies of other distant galaxies, could change our understanding of star formation and galaxy evolution throughout the history of the universe. This is just the beginning of the innovative CEERS study. Until now, we have been based mainly on theoretical assumptions about the early universe. Now, thanks to the Webb telescope, not only can we see black holes and galaxies at vast distances, but we can measure their properties precisely. The amazing power of this telescope is giving us data that will help explain how early black holes formed. They will revise our ideas about the growth and evolution of black holes in the first 100 million years of the universe. The discoveries by a team of researchers with the Webb telescope open new horizons for our understanding of the early universe. We will be able to delve more deeply into the processes of star formation and galaxy evolution, expanding our knowledge of how the universe evolved early in its history.